and sigma notation. Let's begin with what is a series? A series is created when terms of a sequence are added together. So in the previous video, we looked at what a sequence is, and sequence is just a set of numbers in some kind of order. If you add those together, it is now called a series. A sequence, therefore, or series can both be either finite or infinite, and a finite series has a fixed number of terms. For example, here is a finite series. If these numbers were just written with commas in between, that would be a sequence. But now we've put plus signs there, so we're adding all the terms in a sequence. Now that is called a series, and since this series has a beginning and an end here, it is finite. An infinite series continues indefinitely. For example, here's one. We have 10 plus 8 plus 6 plus 4 plus ... Those ellipses there mean this will go on forever. So again, if this was a sequence, you would just have 10, comma, 8, comma, 6. But we're adding the terms now, therefore it's now a series, and it goes on forever. It is infinite. Okay, to help us with series and writing out the addition of terms in a sequence, we can use sigma notation. So this is called a sigma notation, and this is actually the Greek letter sigma. That's why it's called sigma notation. It is called the summation sign. Okay, basically anytime you see that symbol, it means you're taking the sum or you're adding things. And you might see that on your computer or on Google Sheets or somewhere. Okay, so an example. Here we have this. Here we have the sum sign, so we're going to add some things. And what are the things we're going to add? Well, the things we're going to add are here. It's I, but I says we go from 1 plugged in for I all the way up to 7 plugged in for I. So, and these you always assume they go in order. So you're going to plug 1 in there, 2 in there, 3 in there, 4 in there, 5, 6, and 7. And then you're going to add all those things up. So what this symbol means here is find the sum of I for I values from 1 to 7. Again, you would just plug in 1 through 7 for that and add all those numbers up, and that would be what that summation is. Let's look at this one. Same thing we have here. We have, this is our rule here, 3n plus 1, and then we have summation, so we're going to find the sum of a bunch of terms, the first term being the one when you plug n equals 1 in there. So if you put n equals 1 in there, you get 1 times 3, 3, 4. You get 4. And then you put n equals 2 in there, 3, 4, 5. So you're going to get 1, 2, 3, 4, 5 different things, and you're going to add them up. So this means find the sum of 3n plus 1 for n values from 1 to 5. Let's look at some examples of that just to make sure we're clear how it works. So here's a function, for example, or like a general rule for a sequence. U sub n equals n minus 3. So the first 3 terms in that sequence would be what? Well, you could put n equals 1 in there and 1 in there, and you get negative 2, and n equals 2 here, so minus 1, and n equals 3, 3, and you get 0. So here's our first 3 terms, if you put 1, 2, and 3 in here for n. Now that is a sequence, it has the commas. To write that in series notation, we just write the same sequence, but now we're adding all the terms, right? So now the commas are gone, we're just adding those terms. That's now a series. And then that series in sigma notation would be like this. You are finding the sum of n minus 3, because that's our rule, and you're doing it for n values from 1 to 3, right? Because we did the first 3 n values, so we're doing n equals 1, 2, and all the way up to 3. And that's how you'd write that series, like this. Okay, let's try that for this one. What are the first 3 terms of this sequence produced by this function? Well, they are 2, 4, and 8. Because if you put a 1 there, you get 2 to the first power, 2. Or if you put a 2 here and 2 here, you'll get 2 to the second power, 4, and so on. Now in series notation, just adding the terms in the sequence. And then in sigma notation, we're finding the sum of 2 to the n power, so sum of that rule using n values of 1, 2, and all the way up to 3. Okay, I hope that makes sense. We're going to use that in some other problems here. So here's another example. Let's say we had this rule here, 3n minus 2, and we're saying for n values from 1 to 5. So you can see first 1 was put in there for n, and then there's that whole rule with 1 put into it. Plus, because we're doing summation or series, plus 2 is now put in for the n, so we're adding that thing with a 2 plugged in. Plus, now a 3 has been plugged in for n. plus 4 has been plugged in for n, plus 5 has been plugged in, right? So there's the sum of those 5 terms. And if you do that, if you're doing the work in your head, you know if you put a 1 in there, it turns out to be a 1. So here's a 1. If you put a 2 in here, it turns out to be a 4. So 1 plus 4 plus 7. And there it is. There's our series, and there's our final sum of that series. So I hope that that example clearly shows how this process works. Let's see if you can do these 3 here. So try this one. Expand this sigma expression into series form, and then find the sum. So the first one, it says n equals 1 through 4. So when n equals 1, we get this. When n equals 2, we get this. N equals 3, and n equals 4 gives us that. So 4 terms are being added in the series. Our sum is 2. Try the next one. All right, our series looks like this. It has 3 terms in it because we're putting x equals 1, 2, and 3 into this. There's our 3 terms that are added, and we have a sum of 5. Try the last one. In this case, n values are from 1 to 5 are put in there, so we get this series, and we're adding them because we're doing a summation. Adding those, and we get a sum of negative 245. Be careful how this 3 works here. When you have a negative number here, and this is an odd value power, it will stay as a negative number, so these are all negative. Great. All right, hope you did okay on those. Let's try some of these. Here's some more. These get a little trickier. Here's another one. Try this one out. Okay, for A, we have that answer, 10, final answer of 10. Check your work carefully here. Try B. All right, in B, here's the values we get, and the final sum is here. And finally, try C. Okay, a lot of this is just algebra or knowing how to substitute values correctly into equations. Here's C, check your answer there. Again, if you got any wrong, take a close look there and make sure you understand how to use exponents. Okay, so this one, now we're going backwards. In this last one, you had the summation form and you had to find the sum. Here you're given this form and now you have to write it in sigma notation. So see if you can do the backwards method here. First step is to find a rule for that, right? So think about the work we were doing earlier to find rules for that. Can you find a rule for this one? Because once you have the rule, writing the sum symbol is easy. Okay, let's check A. So in A, we know this is negative 3. We know the next number can be created by doing negative 3 plus 8. The next number can be created by doing negative 3 plus 16. The next number is negative 3 plus 24, and so on. So you can see there's a negative 3 every time there. It's just a matter of what number is being added to negative 3. So in the first one, let's see what we got here, negative 3 plus, yeah, negative 3 plus, and this is, let's see, 0. Okay, so yes, this first one here is negative 3 plus nothing, right? So that means negative 3 plus 0 eighths, because all the other ones have some form of 8 added to them. So the second one, if you look at this one, it's negative 3 plus 1 times 8, because 1 8 has been added to negative 3. And the third one here, it's negative 3 plus 2 eighths, right? So negative 3 plus 2 times 8, and so on and so on. Take a look how these matches this. And then that allows you to create the rule, because we know the rule will always have negative 3 plus and then 8 times some number. And the number is 0 first, and then 1, and then 2, and 3. So that number is not the term number, because in term number 1 we see a 0. In term number 2 we see 1. So it's always 1 less, and we've seen that before. So it's 8 times 8 times n minus 1, but in this case it kept as an n. So a lot of students get caught up on this part here. Let's take a look. If you keep that as n, so you're saying n, if this first one you're calling this n value of 0, and this one n value of 1, and n value of 2, then the sigma notation must change, right? Because here n of 0 must go in here. If you're calling that n here, then that must be 0. That means the first n value must be 0. And that's okay to do that. It doesn't always have to be from 1 to some number. It can also be from 0 to some number. So in this case, first n value is 0, next n value is 1, next n value is 2, and you can see it goes all the way to 4. Alternatively, you could have used n minus 1 here, and then this would be then 1 through 5. So that's, you might want to write that down. Yeah, try that. Try doing n minus 1 here in parentheses, and then this would become n equals 1 to 5. And just double check that that makes sense to you, because you should be familiar with both ways. Okay, try B. All right, in B, we have a geometric series, and we can see this is like the same as negative 3 times 1, and this one here is 3 times 2, and this one here is negative 3 times 4, and then 3 times 8. So it's written it out there, and now you can see it's negative 3, 3, negative 3, 3. So it alternates between negatives, so we'll have to do that in a second, but also we have this number here, 1, 2, 4, 8. So you have to think about how am I going to create 1, 2, 4, 8? Well, 2, 4, 8, you can see those are powers of 2. This is 2 to the first power, this is 2 to the second power, 2 to the third power. So we know the rule must include something like 3 times 2 to the n. However, there also has to be that changing from negative 3 to 3, negative 3 to 3. And the way to do that in a sequence is to just insert this. Notice how this negative 1 has been inserted here. So if you put a negative 1 in there, so instead of the rule just being 3 times 2n, we have 3 times negative 1 to some power, which we'll talk about in a second, but also the 2 to the n. So the 3 and the 2 to the n are there, but now this negative 1 is to the power n plus 1. And again, this one started at 0 because we noticed this first one is to the power 0. So then n can start at 0 and go up to 1, 2, and n can go up to 3. So 3 here. And then this here, so imagine you put 0 in here for n equals 0. So you put a 0 in there, 0 plus 1 is 1, so we have negative 1 to the first power, which is negative 1. And that would make the first one turn into a negative 3, which works. Let's try out the second term where the 3 has to be positive. So in the second term, we're going to put n equals 1 because we start at 0. So second term, we're going to put 1 in there. So 1 here makes this a 2. And that means negative 1 squared, which will make it a positive 1. So the second one will end up being positive because this turns positive with a square there. And then meanwhile, you have a 1 on there, which means 2 to the 1. So this slide in particular, I would say spend a little time, take a look closely at these, try these ones using the n minus 1 here, change that to 1 to 5, and just see what you can come up with. Most students find this a lot more tricky, but a few minutes just trying some things out and writing things out, you'll figure it out. And the last one, C, let's take a look at the rule there. We see 8, 12, 16, 20. And then that rule can just be this rule, for example, because this is actually 4 times 2. This is 4 times 3, 4 times 4, 4 times 5. So it's 4 times 2, 2, 3, 4, 5. So 4 times 2 first, so that's a 2 first. 4 times 3 next, which will mean, and then so on and so on. It has dot, 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 so we do to infinity here. So a little tricky, and again, I started with 2. So remember that you don't always have to go 1 through some number. Here we have 0, here we have starting at 2. Alternatively, if you wanted this one to start at 1, so here's an alternative for that, you could have 1 there. But in that case, this has to be n plus 1, because if you put a 1 in here, it will give you 4, but it needs to be 8 to start, right? So you need to do 4 times n plus 1. It needs to be 4 times 2 to get your first number of 8. And to get a 2 here, you need a 1 plus 1. Again, study these carefully. For a lot of students, it just takes a few minutes. You'll figure it out. And that's the end of both video lessons. Now you're ready for a practice assignment, but we're going to save that for class next time. So you've watched these videos, you've studied this, you've taken notes, you've tried these ones particularly backwards and forwards, and then come back tomorrow. We'll do some practice work in class together, and hopefully as we do those practice problems, all this will become more and more straightforward for you, and you'll become more confident. You can do it.